Hello everyone, welcome to class 9 of manual software testing training. In this class, we are going to learn about the incident management or defect management. Now, why I call this class as an incident management? Because there is a brief difference between when we say incident and defects. Okay, so let's understand that difference and then go ahead and understand the defect life cycle and defect management within software testing. Okay. So the first thing basically to understand is what are incidents. So an incident or an incident is any situation where the system exhibits questionable behavior, right? That's why we call it as an incident, because incident and defect are two different things, right? So when we say incident, it is any situation where the system exhibits a questionable behavior, okay? And not necessarily an incident will turn to a defect, right? Or incident will be a defect, okay? Because incident could be because of many other possible reasons as well. And that is why we call incident is any situation wherein system exhibits any questionable behavior or software exhibits any questionable behavior. Now, an incident is any event occurring where actual results vary from the expected, which is same for the defects as well, right? So if there is any variation from expected to with the actual, that's the incident. And any inconsistency between actual and expected result caused by, for example, test environment or developer code, test data, hardware, invalid expected results, right? Or tester mistakes. So any of this can lead to that inconsistency between expected and actual, right? Now, an incident is a bug or a defect only when the root cause of that incident is some problem with the item being tested. Okay, so that's the basic difference between when we say incident and a bug. Okay, so an incident is a bug only if when you do a root cause analysis and you figure out that yes, this variation of expected with the actual is because of the problem, because of the problem with the item that is being tested. Okay, the module that you are testing, the software that you are testing, it is because of that module or the item that you are testing, not anything else. For example, it could be that expected is not actual, expected result is not equal to actual result because of the mistake of the tester itself. Tester is not following the right process. So that is not a defect, right? But that is an incident. That incident is an occurrence, or it will then trigger a option or trigger a reason for doing the root cause analysis. And then in the root cause analysis, when the tester goes into deep, and they'll figure out they were not following the right path or the right sequence of the test that they should have followed. Okay, so if that's the case, then that is not converted into a defect. But say, for example, the module they are testing, they have followed everything properly, the test data, the sequence, everything, and the problem is within the module, then that incident is known as a defect. Okay, so this is the basic difference between incident and defect. Most of the time you will use incident, defect, bugs synonymously in the project, but usually incidents practically won't be used a lot. Most of the project practically, wherever you will go, you will use either defect lifecycle or defect management, or bug lifecycle and bug management, etc. So what are incident reports? So incident report is nothing but contains a description, which is basically, now you can say, if say for example incident is a defect, or incident report or report or defect report, it will describe the questionable behavior, right? And usually only if the incident converts to a defect, practically that's how you then write the incident report, right? In some cases you might also write on even if the defect is not being converted or incident is not being converted into defect or bug, just to make sure that the incident is being analyzed, is being done, the root cause analysis is being done, and then the overall decision has been made whether it's a defect or bug or invalid, right? So it's a incident report is a description of questionable behavior. It helps to have a clear goals in mind when writing, and provides the information about incidents to the team member. So if there is any questionable behavior, you go ahead and you log that into a report. There is a template, there are tools that will provide you to basically log the bugs and defects. So same thing. Now it helps to analyze the incident data. So based on the steps that you mentioned in the incident report, the testers, developers, they can go ahead and do the root cause analysis. You yourself can do or assign to someone. Say for example, as a tester, you are not able to go ahead and do the root cause analysis and you have done whatever you should have, then you assign it to developer or somebody else who will be able to help you out with the root cause analysis based on the incident data and steps that you put. And incident report analysis data eventually helps to improve the test process, right? So overall, based on these incidents that you log, if say for example there are many incidents that are based on, or the cause for those incidents was the mistakes from the tester, not following the right process, not following the right data, okay, then in that case you know, okay, these are the incidents that were rejected and not necessarily a defect. This is something related to the process. We will go ahead and improve the process so testers are well equipped to follow the right process and right data. Okay, so that's why the incident reports are there and what all needs to be included in the incident report. Now, how to write a good incident report? So always be attentive while running the test so you do not miss any incident. Try to reproduce intermittent issues, right? And add as much information as you can related to any of the intermittent issues. Okay. Then isolating the issue is very important by changing the steps used to reproduce. Okay. Mentioning steps to reproduce, mentioning the environment, the impact of the incident. Okay. Use clear, unambiguous and neutral language. Okay. It shouldn't be a sort of a blame game that this problem is because of this code. So it's not about blaming the developer or somebody else about any of the incident or the issues that are being raised. And then it should be concise, not too much information goes there. So step by step, steps to reproduce, expected result, actual result, right? So all of that needs to be there. And it is recommended that all reports are reviewed by lead tester or experienced tester before you actually go ahead and log it in the tool. So this is briefly what all key information should be required in the good incident report. Now I have already created a separate video to how to log the defect, what all key details need to be there. So you can go ahead and search for that video on the channel in the previous series of the software testing, and you will get that detail of how to write a good defect report and the incident report. Practically that's there. Okay. Now, what is defect detection percentage? Now, if you're working with the defect management, obviously you need to understand about the defect detection percentage or DDP. Okay, so defect detection percentage compares field defects with test defects. When we say field defects, it is something, the defects that are found after the product has been released, okay, or in production, that after production, how many defects have been found. Then it is a very helpful metric to find the effectiveness of the test process, right? So defect detection percentage helps to find the effectiveness of testing. Why? Because after release, how many defects were found, and prior to release, how many defects were found during the testing, okay, during the testing phase. So the simple formula for defect detection percentage is that defects that are found by the testers during the project phase divided by defects that are found by testers plus the field defects, okay, and that's the basic percentage of defect detection, and that percentage shows how effective was the testing process. Say for example, 100 defects were found during the testing phase, okay, and no defects were found in the field. After production, everything is absolutely fine, right? So 100 divided by 100 plus 0, because 100 defects were found by the testers plus no field defects, so 100, okay, so 100 divided by 100 is 1. So defect detection percentage is 1, which is highly effective, okay. Now, if say for example 100 defects were found by the testers, but then another 100 were found in the field as well, okay, so 100 divided by 100 plus 100, which is 200, okay. So in that particular case, the defect detection percentage is basically 1 by 2, right, which is basically 0.5. Now defect detection percentage is really bad in this particular case, okay. So the team is not able to find out or figure out most of the defect that should have been found during the testing phase, because if there are so many defects found in the production or in the field, that's not a good thing. So DDP or defect detection percentage helps you to figure out the effectiveness of testing. Very important metric, very widely used in any of the projects, okay. So what goes in the incident report? So some of the key details that need to go into the incident report is basically the summary. Obviously, the summary you need to put what exactly you are raising the defect for. Then the steps to reproduce, different steps that will help you to reproduce or help somebody's developer or anyone who is working on that particular defect to reproduce that same issue into the environment. So those steps need to go. Then expected and actual results need to go, right? So what was expected when somebody performs these steps, but what was actual result in that particular case? So that needs to go there into the incident report. Then software version, very important, software version where the defect was found, phase where the defect was found, right? Incident was found, the test environment that was used to basically figure out or run this particular test case, which test case was being executed when this defect was found or incident was raised, right? Any other reference to the documents, any log files, screenshots, impact of the incident. So these are some, right? These are some of the key points, but not everything as such, right? You need to, if you have the access to logs, attach those logs, take the screenshots of the incident or anything that you can see that it will be helpful, go ahead and attach it, right? So all of these information need to go into a good incident report. All right. Now there is an IEEE 829 standard test incident report template. So test incident report identifier, the summary, then you have the description, right? So inputs, expected results, actual results, any anomalies, date and time, procedure step, environment, attempts to repeat, testers and observers, right? So basically most of the projects, all of these things are basically tweaked as per the details that we have seen here, right? So basically expected, actual result. Now this is the template just for the reference, okay? But most of the organizations, they follow a customized template that best works for them, okay? But then some key information you will find everywhere in the incident report is all about basically these important steps, the summary, steps to reproduce expected result, actual result, the version. All of these are basically a common practice that you will use everywhere in the projects. Okay, now let's go through the defect lifecycle or incident lifecycle. Okay, so basically what happens when there is some anomaly, when incident is found or defect is found. So usually this is very basic one, okay, and some projects might have customized this life cycle. Now life cycle, if we talk about, it is the process that a defect will follow, or when you raise an incident, it will follow from the open state, from the new state, open state, till the closure, right? So if you have this process defined into any of the tools, say for example you're using application lifecycle, HPALM, okay, it has a specific defect lifecycle. If you're using JIRA, okay, JIRA has the workflow concept, so you can manage the bug or defect within JIRA itself. So you can raise a defect, it will go into open, then you can customize that workflow as well based on the need of the project, okay? So you can have different states in the workflow and you can then move the defect or the issue that you raise into those different states until the closure. So basically when we say defect lifecycle, it is nothing but the journey of a defect or the process the defect is going to follow from the initiation, basically when the defect or incident is found, until the closure, right? So any work item within the project needs to follow some sort of life cycle or process. So defect is nothing different. Defect has a separate process to follow so that they are tracked well, they are not missed somewhere. When a proper defect life cycle will be followed, they will be tracked properly. Everyone in the team will know how many defects are there in a particular state, whom they are assigned, how many of them are fixed, how many are reopened. So all of this is the help that you will get based on the defect life cycle and when you follow defect life cycle in any of the tools. So most of the test management tool will have this by default, and this can be customized. There is an underlying workflow that can be customized as well. So when, say for example, defect is open, right? So you found an incident, there is a discrepancy, you open a defect or you raise a defect in a tool. Say for example, you are following JIRA or you are using JIRA. So in JIRA, you go ahead and you log a defect, or you open the template and you select the drop down as bug or defect, and then you create it with all the information that that needs to be there into the incident. So the defect will come into the open state. Now in the open state, there will be a defect triage that happens, basically wherein the validity of the defect, a little bit of root cause analysis will be done, or maybe prior it will be done. Based on that, it will be identified whether it's a valid defect. Yes, if it is valid, then it is assigned, okay, to assign to someone to fix it, to work on it, some developer. Then once it's assigned to a developer will fix it and will move the state of the defect to fixed. Now once the defect has been fixed, the developer will reassign, or basically change the assignee of the defect to tester back. Okay, so after moving it to the fixed state, they'll move it to the tester to test it, assign it to tester. So tester knows that it has been moved to fixed and it is assigned to them to retest, right? So they will then go ahead and verify. If the verification is successful, they'll go ahead and close it, right? Pretty simple flow. Now, in case the retest failed, verification failed, then they'll go ahead and reopen. So the defect will get moved from fixed state to reopen. So the tester will reopen it. Once the defect has been reopened, okay, it will then again be analyzed that it's a valid defect, and then it will be approved for re-repair, or basically refixing, again assigned. Okay, then this cycle goes on until the defect gets fixed and verified successfully and closed. Okay, say for example, during the open, the next example, once the defect has been raised, it is not a valid defect, not a problem, then it will directly from here itself, it will go into the rejected state, stating not a problem as a resolution. Okay, if it is open and then it is identified that yes, it is a valid defect but not very critical, and we can go ahead and fix it into the next release, because this release we have other high priority items to complete. Then in that case, what they do is the team can defer, or the stakeholders can defer a defect, okay, until certain weeks or dates based on the release, right? So it will be planned to be fixed later, it will be moved to the deferred state, and then whenever there is a time to pick the deferred defects, the deferred defects will then be picked up after gathering new information and reopened, and basically then assigned for fixing. So this is very basic flow. This is on a high level everywhere. You will get it in the project, right? The naming of the states might be different a little bit, but then overall this flow is kind of standard and very basic that you will find almost everywhere. There could be more phases or more statuses in the incident lifecycle based on the project needs. It is not hard and fast that only these many states will be there. Okay, there could be a little more states as well and little more workflows based on the project and the test teams and development teams need. Okay, so this is what the defect lifecycle or incident lifecycle is all about. Now, tips for reporting defects or failures. So whenever you are reporting defects or failures, make sure that you communicate defect or failures in a neutral way, right? Usually I see a lot of people always talking about when tester raises a defect on Friday, how developers feel. A lot of memes, go around. That's not the purpose of testing or working as a tester or a developer, right? There shouldn't be any sort of a siloed approach. Now the things have changed. This used to happen a lot previously when we used to follow traditional development approaches and the teams were working separately. There was not too much collaboration between the teams, right? So now there should be a lot of collaboration between the development team and shouldn't be a blame game at all. So when you are reporting any of the defect or failures, make sure they are in neutral way. Do not gloat, do not criticize or blame a developer. Be always constructive and discuss defects with the developers, because quality in Agile is everyone's responsibility. It's not just that testing team will be blamed and should be blamed basically that the defects are being leaked. It's the whole team's responsibility, and that's why when you are reporting defects or failure, you need to be really neutral. Okay, then you need to explain that by finding the issue earlier, we can deliver better software, right? So this is basically something which will come naturally when you are not in a blame game sort of a thing. You will go ahead and discuss with the developer that yes, we can deliver together a very good software and good quality software, right? You are in the team to help everyone to deliver a quality product. Okay, that's the discussion and communication. That's how it should be happening. So mention what worked in the software. So always mention, praise. Basically, developers are also doing great work when they are developing something. So everyone is human being. There might be mistakes happening with everyone in the project. So whatever has worked really well, always try to mention that things have worked well in this particular area. And then what hasn't worked well, make it sure that it is neutral, communicated in a neutral way. And then prioritize the defects properly. So you shouldn't be prioritizing everything as critical, right? So that is not how you are going to raise defects. So make sure when you are raising defect, they are prioritized properly. If there is a critical or blocker defect, make sure it's prioritized, or it's marked as blocker only if it is actually blocking the testing, right? Not every defect can be a blocker or critical. And don't always be pessimistic. Okay, optimism is important, and don't be pessimistic, and that's how you will work together as a team to deliver a good quality product. Okay, so this is basically some of the details about the defect management in the software testing. In the next class, I'll discuss few more manual software testing concepts. So that's all for this tutorial. Please go ahead, subscribe if you haven't subscribed, press the bell icon, share this whole tutorial series with anyone who is looking for software testing job and want to learn the software testing concepts practically. So this is all my experience, all years of experience basically I'm sharing. So go ahead, share this whole series with anyone of your known contact, colleagues, if you're in college, with your college mates, and I'll see you in the next class. Thank you very much for watching.